In the third section, we will be learning about gameplay tags. In our game, it would be really helpful to label certain things. Like for example, this fire area could be an element fire, this sparks area could be an electric element, this bottle actor could be like a water element, whereas this tango actor could be like a grass element. This could be a rock element, and we can label if this damage taken would be physical damage, or if this healing fountain is a magical effect. So we can label and identify certain things in our game. So these labels can be used to identify or label any actor, or to indicate an event, or to modify the state of an object, like even if any character got stunned or silenced. Unreal Engine employs something known as gameplay tags for this kind of labeling. As we saw in our gas solar system, gas understands the universe with tags. These gameplay tags are like light and sound in the gas universe. Now, what exactly are gameplay tags? In the Epic Games developer documentation, gameplay tags are certain labels which are user-defined. These labels have hierarchical levels, separated by the dot character. So kind of like how in biology, in the animal kingdom, you learnt about kingdom, phylum, class, order, family, genus, species. These gameplay tags follow such hierarchy, and it will be represented in the syntax family.genus.species, where the family tag has the child tag genus, and the child tag genus has a grandchild tag species. So in your game, if you have a dog, you could name it animal.mammal.canine, and a cat animal.mammal.feline. Similarly, for a snake actor in your game, you could label it with the animal.reptile.crawl gameplay tag. And maybe for eagle, you could maybe use something like animal.avian.hawk. But for something like a bat, you could either call it animal.mammal.avian, or you could call it animal.avian.mammal. So game designers can face such kind of discrepancies, and hence tag management becomes very crucial, especially when trying to label and identify many elements. So in your Unreal Engine project, the generic ways of adding gameplay tags includes using the small dialog box that opens up whenever you're dealing with tags, where you have an Add New Gameplay Tag section, and there you can name your gameplay tag, and you can name it separated by the dot character. And the second way is in the Edit menu's project settings, and in the gameplay tag section, you can see the gameplay tag list property, and similarly you have the same box where you can add any gameplay tags you like. And these gameplay tags will be specific to this project and not any other Unreal Engine project. Although you can add tags in this manner, let me show you a more organized way to create and add tags to your project. We will be using something known as JSON files. If you come from the web development background, you may already know how JSON files work, but let's quickly get to know what is JSON. As per this Wikipedia article, JSON is a data format to store and transmit data objects consisting of attribute value pairs and arrays. Something like this. JSON actually stands for JavaScript Object Notation, and this attribute value pair is a notation used for objects in JavaScript language. And so this can be information to describe a person, where you have many different attributes like first name, last name, age, address, and so on, and their relevant values. Notice that the value of one attribute can itself be another JavaScript object, and you can also have arrays containing more JavaScript objects. So gameplay tags can be added to your Unreal Engine project using a JSON source file. This JSON source file is required to be of a particular format. It should be a list of JavaScript objects, and each object has these three attributes: name, tag, and developer comment, or dev comment. So name is literally your gameplay tag, and for tag, I will use the same gameplay tag as the value. You can write an optional developer comment. So this JSON file called tags.combat is used to create many gameplay tags pertaining to gameplay combat, like combat.attack if you're basic attacking, combat.melee.hit if a melee hit has occurred, combat.range.hit when a ranged projectile hits any actor, combat.block.parry to label a particular parry window, dodge perfect, dodge reset, and so on. Notice how the grandparent tag is combat. It can have a child gameplay tag, and that itself can have 2 or more children. So as game designers, you want to get really creative about it and design your gameplay tags in an organized manner. in the tags damage heal JSON source file, I have a list of gameplay tags for the different magical elements, like the air element, the water element, fire element, earth, electricity, and maybe a void element. I also have a basic damage tag, and creating this heal.fountain tag will also create this parent heal tag, so I don't have to independently create a new heal tag. So you can see that I have damage.periodic, damage.type.physical, damage.type.magical, and damage.type.pure gameplay tags. And finally, in the tag state JSON file, I've specified the gameplay tags for different disables, like in Dota 2, where you can have silence, disarm, root, and the intersection of all, the stun. I also have gameplay tags for the other disables like mute and break, and another gameplay tag for the invincible state, which can be used for certain invincibility frames. I have created these JSON files in a tags folder within my project's root directory, and now these JSON files are ready to be imported into my Unreal Engine project. So in your Unreal Engine editor, you will have to import these gameplay tags using something known as a data table. So I've created a third new folder called model, and within this model folder, I have 3 data tables. Each of these data tables have the gameplay tag table row. So right click on an empty space, and in the miscellaneous section, click on the data table option. Search for the gameplay tag table row. So each row of this data table is now meant for a new gameplay tag. So click on OK to confirm, and now open up your new data table. You can see that this data table is empty, and you can see the 3 properties of this data table: the row name, tag, and developer comment. So actually clicking on that will sort it alphabetically. So you can click on data table details panel, and in the file path category, you have the source file property, where we now have to specify our JSON source file. So click on this browse button and navigate to your projects folder. Notice that it also accepts the CSV file. I will open up my tags folder and choose one of the JSON files. And if I click open, you'll see now the source file has been populated with my external JSON source file. Now in order to populate your gameplay tags here, you can click on this re-import button. And notice how all of your combat gameplay tags has been imported into this gameplay tag data table. Clicking on this add button will also allow you to create your own gameplay tags within this data table without any JSON source file. So I can name my gameplay tag like so, but you'll have to manually rename the new gameplay tag row, which is why I don't like that method, and you could rather use a new JSON source file. So let me close this class and delete this data table. And this doesn't simply add these gameplay tags into your project. You still have another step. So in your edit menu's project settings option, and in your gameplay tag section, and you'll notice I've already added my gameplay tag data tables. These are the data tables for my gameplay tags for combat, the damage heal elements, and the pawn states, which I had shown in the JSON files. I will now delete all of these data tables. You will notice that that cleared all of my gameplay tags in the list. So now you can just add a new gameplay tag by clicking on the add element for the gameplay tag table list and choosing your appropriate data table. And as I chose my combat data table, notice how I got my combat tag and its children tag. And these children further have grandchildren gameplay tags. So I shall add my other gameplay tags as well. And notice how I got all of those gameplay tags in my list. Notice how I have the parent heal tag even if I had declared only the heal.fountain. You can also read the tooltip developer comment. So now these gameplay effects can be used to grant these gameplay tags onto this ASC actor. So let's start with the gameplay effect burn damage. So after specifying the duration and the modifier magnitude and specifying the periodic interval, if you scroll down, you'll see that there's a tags category, and you will see many properties pertaining to gameplay tags. So in Unreal Engine, you also have something known as a gameplay tag container, which is actually a collection of these gameplay tags. So this granted tags property is used to apply these tags to the actor under this effect. So don't worry about combined tags, we don't have to modify that. So this added property is actually a gameplay tag container for several gameplay tags. So you can specify one or more tags that you can grant to the actor under this effect. So I think I'll use tags such as damage.type.magical and maybe element.fire. And I'll maybe also specify that it's a damage.periodic. So this is what a gameplay tag container looks like. It has a collection of these gameplay tags, and optionally you can also remove these tags. So if you compile this class, notice how the combine tags now indicates your added tag and not the remove tags. So if you also chose the element.fire in the remove property and compiled, the combine tags is actually the added minus the tags you removed. So don't be concerned with this combine tags property, and I will just simply clear all of the remove tags property. And now if I play my level for this ASC actor, you will notice that I have these granted tags: damage.type.magical, element.fire, and damage.period. Under this fire effect, even if my health did not reduce. So even if the health doesn't change, doesn't mean that effect has not been applied. Similarly for this bottle actor, let's grant a tag to this ASC actor. That is actually in my gameplay effects attributes heal duration. And in the granted tags, I shall maybe add element.water. Now you can read the tooltips of these other gameplay effect tag properties, like gameplay effect asset tag, granted blocked ability tags, ongoing tag requirements, application tag requirements. And so now you can operate on this effect, that is remove or block, or apply only under a condition, or under an ongoing tag, without any code, but only using gameplay tags. In the Chapter 3 second topic, that is the sprint effect, we will implement the ongoing tag requirements. Note that the granted tag won't be applied during any instant effect, but the effect still bears that tag in its property. And in this manner, you can grant gameplay tags to an ASC actor under that effect. So this proves how effective gameplay tags are in any Unreal Engine project, even beyond the gameplay ability system. As a best practice in GAS, it is a good idea to label everything with gameplay tags, so they need not be queried by their classes, like whether I'm a hero or a minion. Now gameplay effect classes are just one of the ways to apply a gameplay effect. Gameplay effects can also be applied using something known as the gameplay effect spec. The GAS documentation project has some information on the gameplay effect spec. It states that these gameplay effect specs are pretty much the instantiations of gameplay effects. Technically, these gameplay effect specs are certain structures, just like the F gameplay attribute data. They can also be constructed using a gameplay effect class. It stores the level of that effect and also which actor actually created that effect. So technically, whenever a gameplay effect class applies the effect, a gameplay effect spec is actually created from that gameplay effect class. And under the hood, that is actually what is applied to the target. So we can create these gameplay effect spec structures using the ability system components make outgoing effect spec, which is actually blueprint callable. Note that whenever a gameplay effect is applied, either through a spec or a class, it always returns a new structure known as F active gameplay effect. This is not the same as the gameplay effect spec. And one last thing I almost forgot to mention, the spec word actually stands for specification. So technically, it contains the effect specifications. So this gameplay effect spec has a lot of content within it, and we will explore and unwrap that in the next section. So now in my burn area actor, you will notice that for the box overlap event, I am applying a gameplay effect class. So as we learned in the GAS documentations project, we will use the ability system components make outgoing spec method. So this make outgoing spec, this method requires 3 parameters. One is a gameplay effect class, for which I shall pass the gameplay effect burn damage. I shall keep the level 0 because we're not using the level for any kind of value calculations, which can actually be done using these curve tables. These curve tables are for another topic. So now you can see that it returns something known as a gameplay effect spec handle. So let's filter for apply gameplay effect, and we will choose the apply gameplay effect spec to self. And so we can pass this gameplay effect spec handle into this apply gameplay effect spec method. So let me just connect that, compile this class, and when I play my level, let me first consume my health. The gameplay effect burn damage has still been applied. Now these effect specs can be important because we can modify its values within that effect specification. Although that's not possible in blueprints, it can be done in C++. Now let's suppose I wish to change the damage of this fire effect. So since I've already mentioned the damage of -5 every 0.5 seconds, how could I possibly change this damage value? So this can be done using something known as setByCaller. So that is a magnitude calculation type. So you could notice the disappearance of that magnitude calculation category, and instead you have something known as setByCaller magnitude. Instead of this category, you have two properties, data name and data tag. So what this means is, you can use a tag to capture the value for this magnitude. So let's use a simple tag, such as maybe element.fire. This element.fire is something known as a caller tag, and I can set a value to this element.fire tag, and that value will be the modifier magnitude. And that can be done using something known as assignTag setByCaller magnitude method. So this method is part of the Ability System Blueprint library and operates on that newly created effect_spec handle. You can notice the other two parameters, the data tag and the magnitude. So if I use any data tag here, it will attempt to capture that value by the tag that has been set in any one of these magnitudes. So even if I use the setByCaller over here, I can have more than one caller tags in this gameplay effect. So this magnitude is only being set for that caller tag, and it returns the gameplay effect_spec handle structure, which I will pass in the effect_spec handle. Now I will use an incorrect data tag and maybe a magnitude of -10. Oh, wait a second. I don't think I connected the execution pins properly. So let me just remove that, hook that up there, and this one there, and now compile. And my class has been compiled successfully. Now let me play my level. When I consume that Tango actor, you will notice that no matter how many applications of the fire, I'm not taking any damage to my health. That is because this combat range caller tag was not found anywhere in this gameplay effect specification, meaning I have to use the correct tag element.fire. So let me now choose the correct gameplay tag element.fire and then play the level. And now, after consuming the Tango, you will notice how every periodic tick of 0.5 seconds, I'm losing -10 health. So this allows game designers to modify any of the effect values. Now I have a small task for you. As you did with the burn area, in the bottle actor, I want you to modify the duration magnitude. I want you to make it maybe about 10 seconds. So you can pause this video right now and come back to this when you're done. Okay, I hope you worked on that task. So let me show you my bottle actor class. In this class, after getting the valid ASC from that overlapping actor, I'm calling the make outgoing effect spec from the ability system component. I'm using my gameplay effects attribute heal duration effect, which is what is used by Bottle to add that periodic duration effect to heal my health, mana, and stamina. I call the ability system blueprint libraries assignTag setByCaller magnitude method, and I pass that effect spec handle to its parameter. I also use the gameplay data tag element.water, and as for the magnitude, I created a variable property for this bottle actor class. I've set the duration to 10 seconds. So imagine that if in your game, these bottles or that fire area have their own levels and can enhance in their properties like more damage or more heal duration, then you can use such values dynamically. And then I call the ASC's apply gameplay effect spec to self and passed in that effect spec handle that has now been set a new magnitude for the caller tag element.water. And obviously, for this gameplay effect, I made sure to set the duration magnitude to be calculated using setByCaller, and I pass the gameplay data tag element.water. This data name doesn't work, and as you can hear, no matter what keys I'm typing, it's not really accepting any name string. So I don't think this works in blueprints, and it may be deprecated even in C++. So I guess initially they were using names before Epic Games made gameplay tags in order to set that caller magnitude. I still don't know correctly, but you can always use the gameplay tag. So yes, I can understand what you must be thinking right now. This may be a very unorthodox way of using gameplay tags. It seems to be like a very weird way to set values. It's not like you can overwrite any property value for any effect spec. That is only possible in C++, where you can unwrap this gameplay effect spec structure and access and modify the properties within. So if you need more information on the gameplay effect spec, you can always read the gas documentation's README file. Documentation would be the best source of information to learn anything. So you have so many such properties encapsulated within that gameplay effect spec structure. The gameplay effect class, the level of that effect, the duration and its magnitude, the periodic magnitude, the current stack count, and this is really cool, dynamic granted tags. So these can be new additional gameplay tags that can be granted to the target even beyond that granted gameplay effect tags. And it is best to identify your effect even using its asset tags, and you can add more asset tags dynamically. And finally, the most important thing is, note that these setBy callers are actually maps. That is, for this gameplay effect, gas creates a map of gameplay tag to its value. So if you have multiple such caller tags, then your gameplay effect will have multiple caller tag keys within that setBy caller map, and those values from that map are actually used for those magnitudes. Now you can notice that there's also something known as context in this makeOutGoingSpec method, and this is nothing but the effect context handle. Although you can't really make it or work on this effectively in blueprints, but the ASC has a method called makeEffectContext that returns that effect context handle structure, and that can be hooked up into this context parameter. So in a gas documentation project, you can read more about this gameplay effect context. It is nothing but information about that gameplay effect's instigator and target data, like who is the instigator or the source of that effect or the creator of that effect, and who or what is my target. Now finally, in the fifth section, we will be operating on the health attribute based on the health meta attribute. So in your base attribute set class, include the gameplay effect header file, and then include the gameplay effect extension header file. Now right click on your attribute set class name and click on go to definition. From this class, we will be implementing the PostGameplayEffectExecute method. As you can see here, this method is actually called just before a gameplay effect is executed to modify the base value of an attribute. So this is pretty much the final step of a gameplay effect's execution. So just copy that method declaration, and in your base attribute set class, go ahead and paste that method declaration. You will also have to specify the override keyword since you're overriding from the parent class. Now create the definition of this method, and so in the PostGameplayEffectExecute definition, first let's call the superclasses method. And now in this method, it is time to do the damage or heal using that meta attribute, that is health meta. So just like in the pre-attribute change method, within an if block of code, I will validate if I'm actually dealing with the health meta attribute. I can use this incoming data parameter, which is of the type the fGameplayEffect mod callback data structure. Wow, that's a lot of words. So let's just quickly go to the definition and notice that this contains essential data on the current effect spec, certain evaluated data, and the target ability system component object pointer. So this structure packages these essential properties. And so developers of GAS have provided this data payload where we can operate on essential information. So in order to validate for that attribute, I will use that data parameter, and you can notice that from this data package, I can get the current effect spec, certain evaluated data, and the target ability system component, where if this effect has been applied to self, it would be this very own actor's ASC. So I will use the evaluated data because within it, we have essential data related to the attribute being modified, such as its magnitude, the float value, the modifier operation, which could be add, multiply, divide, override. And so we're going to use this fGameplayAttributeTypes attribute property. So just like in the pre-attribute change method, I shall verify in this logical expression using the getHealthMeta attribute accessor method. Now we know that health would actually be the current health plus any value in the health meta. A positive value is healing, whereas a negative health meta value would be damage. So now how do we set this health value? We can simply use the setHealthAttributeAccessor method. So let me call the setHealth method here, and in its input parameter, it requires a new float value. So for this new value, I shall use that health plus health meta operation. So I can get health using its getter function, which returns a simple float value of the current health value, and I will add it with the current health meta value. Note that I'm actually using the getter function of the health meta, meaning at this time, this health meta has already been set to its new damage or heal value. We will validate this using a debugger at a later time. Now let me just arrange this in a new line. Now this sets the health to this operated value. So now that we have set health, and we have already clamped it in the pre-attribute change method, I still want to clamp it here again. So I shall add this float value into my fMathClamp method, which is inside of the setHealth method itself. So after having passed its x parameter, I will pass 0 as its minimum parameter. And obviously the maximum will use the max health value using the getMaxHealth function. So in this manner, you have set the health, clamped between 0 and the max health, operated upon using the health meta value. And lastly, let me also set this health meta to 0. Its purpose has been done here. It may have had an overridden value from a gameplay effect. Now I have another small task for you. I want you to implement the same for the mana meta and the stamina meta. So pause the video now and return after completing that task. Okay, so I hope you have now completed that task. So you can do the same for the mana meta by first evaluating that effect's modifying attribute and setting the mana using a clamped value of the mana operation with the current mana meta value and between 0 and the max mana. Finally, you can just set the mana meta to 0. And similarly for stamina. Now let's place a debugger here and build and compile my code. Now after the successful build, my editor will open up in debug mode. And now let's work on the health meta. Open up the gameplay effect burn damage and we'll be only modifying one attribute. Search for health meta and choose override. And as we know, in the volume of effect folder, in our burn area actor, we're using a damage value of -7. Let me actually make this value to be about -3.5. So let me compile this class and now play the level. So if I run into this fire area, you'll notice that my code hit the breakpoint. Now here we can inspect many different variables. So this data parameter packages this essential information. We can now see the contents of this effect spec. We can see the effect class it comes from, gameplay effect burn damage. We can see its duration and period. In the modifiers, we can see a single value. Its evaluated magnitude is -3.5. And in the modified attributes, you can see that it has modified our health meta to a total magnitude of -3.5. Also, at this stage in the PostGameplayEffectExecute method, let's inspect this base attribute set object. Notice how our health meta has actually been set to the value of -3.5. So basically the pre-attribute change method was called before the PostGameplayEffectExecute method. Now let me remove this debugger and hit play. And if I add another debugger here, it will stop at pre-attribute change method. And let's place a second debugger within the PostGameplayEffectExecute. So if I hit continue, notice how our second debugger was hit, meaning the pre-attribute change method was indeed called before the PostGameplayEffectExecute method. If I hit play again, notice how it goes to the pre-attribute change debugger. This time it's operating on the attribute health and not health meta. And that happened because of the setHealth method. So even such a setter method will actually call this pre-attribute change method. So now let me run the level without any debugger. First let me consume the bottle actor and then enter this fire effect. Notice how 3.5 is the damage I'm taking every periodic interval, even if we didn't use the health attribute in the modifier. So henceforth in your game, you can always use the health meta attribute and that can be overridden to a raw damage, rather than directly modifying the health. This is a much cleaner way to do it. Also because you can modify this health meta based on armor and magic resist attributes, which we will be doing in the future topic for physical or magical damage types, just as in Dota. And so now this brings me to the end of this chapter. So in this chapter we learned about adding the gameplay ability system and implementing the ability system component. And then in the topic 2, we learned about attribute sets. I hope this video can help you implement this into one of your projects. If you have any queries, leave them down in the comments below. So thank you and see you in the next one.